Good day, Doctor. We are from Group 13. We have two members. I'm Wu Chenhong. Today, I would like to discuss a fascination and intentional mathematical topic, combination problems, particularly focused on distributing objects into different boxes and assigning resources on the constraints. These problems are not just theoretical, they are wide applications in real life, such as logistics, distribution, and task allocation. Though this text, I hope to help you understand the core principle of combination problems and learn how to apply them flexibly in practical scenarios. There are two fundamental principles. Some rule. Suppose that you want to perform a task which can be accomplishable by performing either subtask 1 or subtask 2. Then, if subtask 1 has m ways to be performed, subtask 2 has n ways to be performed, this implies there are m plus n ways to perform the task. Product rule. Suppose that you want to perform a task by performing both subtask 1 and subtask 2. Then if subtask 1 has m ways to be performed, subtask 2 has n ways to be performed. This implies there are m multiply n ways to perform the task. Combination definition is also important. Let's look at a concert example. Suppose you are a cookie shop owner with 3 types of cookies. I need to distribute them into gift boxes. We analyze this for scenario based on whether the items and boxes are distinguishable. This one, both items and boxes are distinguishable. In this scenario, each cookies can be placed into the red box, the blue box. Each cookies have 2 options, so the total number of distribution is 2 plus 2, 2 multiplied 2 multiplied 2 equal 8. Case 2. Items are distinguishable, but boxes are indistinguishable. Then, since the boxes are indexual, we only consider the distribution patterns of the cookies. All cookies in the box, one way. One cookie in the one box. One cookie in the one box, 2 in the other. On these 2 in 3 ways. Each box contains 1 cookie, one way. Total 1 plus 3 plus 1 equal 5 ways. Case 3. Items are indistinguishable, but boxes are distinguishable. In this case, we only consider how many cookies are in each box. One box contains all 3 cookies, 2 ways. One box contains 2 cookies, the other contains 1, 2 ways. Total 2 plus 2 equals 4 ways. Case 4. Both items and boxes are indistinguishable. In this case, neither the cookie nor the boxes can be distinguished. The only concern is the overall distribution. All cookies in the one box, one way. Cookies are Split between the two boxes 1 way. Total 1 plus 1 equal 2 ways. Next, let's look at a more complex problem. Assigning 5 employees to 3 projects under the following constraints. 1. Project P1 must have at least 2 employees. Project P2 must have at least 1 employee. Project P3 can have at most 2 employees or not at all. We can divide this into 3 cases. All employees, case 1, no employees in P3. All employees are assigned to P1 and P2, with P1 having at least 2 and P2 having at least 1. The remaining 2 employees can be distributed as 5 choose 2 equal 10 ways. Case 2. Case 2, one employee in P3. One employee is assigned to P3 and the remaining 4 are distributed between P1 and P2. Satisfying the combination 5 choose 1 multiply 4 choose 2 equal 50 ways. Case 3, 2 implies in P3. 2 implies are assigned to P3 and the remaining 3 are distributed between P1 and P2. 5 choose 2 multiply 3 choose 1 equals 30 ways. Total, adding the 3 cases together, the total number of the wide assessment is 10 plus 40 plus 30 equal 100 ways. The core of the problem lies in the identifying the distinguishability and contrasting followed by solving it using combinational math for special requirements by the detailed analysis and can be conducted. That's all. Thank you.
至该会议。
Hello everyone, today we are going to explore a crucial concept in combinatorics, arrangements with repetitions, which has extensive applications in many practical problems. Simply put, arrangements with repetitions means that when arranging elements, the same element is allowed to appear multiple times. For instance, when selecting elements to form a sequence, an element that has been chosen before can be selected again each time. Now let's understand this concept more deeply through an example of a school sport meeting. The school is holding a sport meeting, and 5 students are going to participate in 4 events: running, long jumping, rope skipping, and tug of war. Each event must have at least 1 student participating, and the student can participate in multiple events. There are 3 problems we need to solve based on scenario. The first question is about the number of ways to allocate students to different events. This is a typical allocation problem. We can use the idea of grouping first and then reallocating. We need to divide the 5 students into 4 groups. And there are two grouping methods. One is 1 plus 1 plus 1 plus 2. And the other is 2 plus 2 plus 1. Let's look at the 1 plus 1 plus 1 plus 2 grouping method first. We select 2 students from 5 to form a grouping, and the remaining 3 students form separate groups. According to the combination formula, we can calculate that termwise of selection. Then we allocate these 4 groups to 4 events. This is a permutation problem. According to the permutation formula, the number of permutations is 24. So the total number of methods for this grouping method is 10 times 24 equals 240. Next, consider the 2 plus 2 plus 2 plus 1 grouping method. First, we select 2 students from 5 which has termwise. Then we select 2 students from the remaining 3 with 3 wise. However, we need to note that there is a duplication problems here. Here, the 2 groups of 2 students are indistinguishable. In terms of combination, we need divided by 2. So the numbers of grouping methods is 50. Similarly, when we allocate these 4 groups to 4 events, the numbers of permutations is 24. So the total numbers of methods for this grouping method is 15 times 24 equals 360. Putting the numbers of methods of the 2 grouping methods together, 240 plus 360 equals 600, which is the total number of ways to allocate students to different events. The second question is about the allocation situation for a specific event. Suppose there are 2 students participating in the tug of war event and 1 student in each of other events. We select 2 students from 5 to participate in tug of war event, and the number of methods is 10. The remaining 3 students are arranged in other 3 events, which is a permutation problem. The number of permutations is 6, so the number of methods in this situation is 10 times 6 equals 60. The third question is about the total numbers of schemes for students to participate in events, since each student has 4 choices. According to the principle of stamp-by-stamp counting, the total number of schemes for 5 students to participate in event is 4 times 4 times 4 times 4 times 4 equals 1024. This is the conclusion. Through the solution to these 3 questions, we have a clear understanding of application of arrangements with repetitions in practical problems. When solving such problems by reasonably using the knowledge of combinations and permutations and company with the principle of stamp-by-stamp counting, we can accurately find the answer. I hope that everyone can easily and similar problems in the future. Thank you.